All right, 8th graders, this is day one of 8th grade science test prep. I'm Mr. Vickery. Here I am. The format will be similar. You'll have 60 seconds to read, think about, and answer each question, followed by a short tutorial of what the correct answer is. If you're ready, you have 60 seconds starting now. All right, the graph below shows the movement of an object at several points in time. What is the average speed of the object? Well, speed is measured in meters per minute in this case. So they're measuring in meters per minute, and that's 1 minute on the bottom. So we want to know how many meters is the object moving in 1 minute. So we have to look at the data here and decide, well, how far is it moving in 1 minute? And it might not be easy to tell by going, well, here's 1 minute, here's 2 minutes, 3 minutes, 4 minutes, 5 minutes, and so on. But what we can do is take a data point such as this last one here. If we just look at one of these data points, we say, well, how much time has elapsed? 25 minutes. How many meters were traveled in those 25 minutes? And how to read the graph is you go up here and you go, at this point I have moved 50 meters. So I traveled 50 meters in 25 minutes. That, if we do a quick division here, 50 divided by 25 gives us 2 meters in 1 minute. Therefore, the speed is 2 meters a minute, and that holds true the entire time. So the choice is B. Next question, 60 seconds, begin. Data from the experiment are presented below. So we have a data table, and these points have been graphed over here. So, if we connected the dots, we could have a nice little line here that we could actually find the slope. You've heard of that in math class, science class. What is that slope telling us? So it says the slope of the graph represents what characteristic of an object? It kind of goes to, what are we measuring here? We're measuring distance over time. And when I see distance over time, so centimeters per second is what we're actually measuring here, I think speed. And here's why. So you think miles per hour is the most common thing we measure speed. So miles per hour. Um, we have a distance unit over a time unit. So distance over some unit of time is all considered speed. So our choice is C in this case. A little longer question here. You have 60 seconds to read and answer. If additional time is needed, press pause on the video. All right, student records the mass and volume of a lump of clay X. Next, second lump of clay Y is added to lump X. When I visualize this question, and you have to have good vision to answer some of these, I imagine a lump of clay X that has a mass and volume, a lump of clay Y that has its own individual mass and volume, and then finally it says we're adding a third lump. We'll call that lump Z, and it also has a mass and volume. We're going to add those all together to get one big lump of what we call XYZ clay. Down here we've collected some data about the mass in grams and volume in centimeters cubed. If we just focus on point X here, we can gather that if we kind of go down here, the volume's about 1.1 centimeters cubed, and the mass is about, moving over, we'll say 1.6 grams. I'm going to write this down as a density, and I'll explain why. When I read the answers over here, I see this word density, and I knew it was coming, but maybe you didn't know, but they want you to calculate the density or estimate the density. So lump X has a mass of 1.6 grams over a volume of 1.1 centimeters cubed. And the reason I know that is because density is equal to the mass over the volume. So we need to find out the same for Y and Z, those lumps. So then we can read the statements. So how would you do this in a minute? Probably, you could think faster than I can talk, but we'll see what happens. So the mass, when I add Y, we see that things have changed. The mass went up by not very much, like just a little tiny bit here, and we could probably estimate that maybe the mass went up about 0.2 grams. I'm going to write that down here. 0.2 grams is the mass of Y. And the volume went up by quite a bit more. If we look at here, we're maybe at like 3.6 for the centimeters cubed. That's not the volume of Y itself, because remember we had a volume here of 1.1. So the difference between these two numbers is 2.5 centimeters cubed. And what we've got, before we do Z, we've got something that's pretty dense here, and Y with not very mass is going to be not very dense at all. It's a very non-dense clay. So let's see what happens with Z. So when I add Z, I go from about 1.8 grams all the way up to, we'll say, That looks about like 2.8 grams. So we'll say Z has a mass of 1 gram. But its volume, it went from 3.6 to, we'll say, about 4.5, giving it a volume of about zero point 0.9 centimeters cubed. Now that we have all that information, let's see what the answer is. Lump Z has the greatest mass. Well, looking at the data we interpreted, is that true? And the answer is no, because X has a greater mass than Z. So A is gone. We're going to eliminate answers to get to the right answer. Lump Z has the lowest density. This is about a density number of 1. Here we're going to have a much, much smaller density in Y. So B is out. Lump Y had the lowest density, and we just kind of figured that out. You don't even have to have the actual number, but we know this is going to be a very small number. So small density, it's not a very dense object. Letter C is probably going to be our choice. I'm going to circle it. And then D, lump Y has the greatest mass. Well, we know that that's not true because we are clear. So we've eliminated all the answers, and C has to be the choice. Next question, 60 seconds, begin. It says red clay bricks have a density of approximately 2,000 kilograms per meter cubed. Air has a density of about 1 kilogram per meter cubed. Clearly, bricks are more dense than air. 2,000 times more dense. This is the old question, which weighs more, a pound of feathers or a pound of steel? That's a trick question because they weigh the same. They are both 1 pound. But let's look at the data and see what are they trying to get at here. So don't be tricked. We know bricks are more dense, but let's see what happens. So we have 2 cubic meters of bricks. Relating that directly back to the number 2,000 per 1 cubic meter, this would weigh, and I'm going to put these numbers here, 4,000 kilograms. That's a lot. That's more than a car. 4 meters cubed of bricks would be 4 times 2,000, or 8,000 kilograms. So even more. So right now we haven't done anything except we're just applying numbers. 6,000 meters cubed of air is going to be 6,000 times 1, or 6,000 kilograms. So we're almost there. 10,000 meters cubed of air would be 10,000 times 1, and this is going to actually be the heaviest item. Do you see where I'm going with the... They try to trick you into thinking that air will be the lowest mass, but it really has nothing to do with it's how much air is there. So let's see, which one's the lowest? Well, the 4,000 kilogram, or choice A. But the only way you can do that is if you systematically go through all 4 choices and decide which one's the lowest. Next question, 60 seconds, begin. How much time is required for a bicycle to travel a distance of 100 meters at an average speed of 2 meters per second? Rather than show you the math, let's try to visualize this problem. Here's my bike. If I can draw a quick bike here. Handlebars, seat, that's pretty close. I need to travel from 0 to, we're going to put it over here, 100 meters. How long is it going to take me? Well, here's the trick. My speed's 2 meters per second. So every second I'm traveling 2 meters. 2 meters, 2 meters, 2 meters, 2 meters. This is taking me 1 second, 1 second, 1 second, 1 second. And it's going to take me several seconds to get to my 100-meter mark. If you think about it, and this is 2 meters, 2 meters, 2 meters, 2 meters, 2 meters, 2 meters, and it keeps going, right? So visualizing, it's going to take me 50 seconds times the 2 meters to go 100 meters. So the choice here, 50 seconds. Next question, 60 seconds. Begin. A break in a rock layer which causes the adjacent rocks to slide past each other is called a, this is kind of vocab, but here would be adjacent means next to each other. So see this rock formation, they can actually slide right here. In fact, they do slide from time to time. We call them earthquakes or tremors. The term is not fracture. It's not where they were broken. It is called a fault line, and that is where when this slides, the earth kind of actually moves or quakes, and we call it an earthquake. So fault is the choice. Next question, 60 seconds. Begin. Two students are pushing a cart as shown below. When I think of this scenario, first off, newtons are how we measure force. So these guys are applying force in the direction of the cart, so they're pushing it towards each other. It looks like guy number 1 here is a little bit stronger than guy number 2. So how do we figure all this out? I always thought of it like this. This guy is going to cancel out 150 of these newtons. So how many will be left? Well, if you subtract, we'd have 50 newtons left. So this guy is going to have a net. The cart's going to move in this direction with a 50 Newton force, and this guy's going to be walking backwards. So let's read the question. The cart will move as if it were acted on by a single force with a magnitude of, well, there's 50 newtons left, so A is the choice. Next question, 60 seconds. Begin. Okay, four forces are acting on a box as shown below. Um, let's see which direction the box will move. So if we think about it this way, let's just start with this force pushing that direction with 30 newtons versus this force. Which force is going to win? Well, the one moving in this direction, so the box is going to net move to the left, so that's going to be true. Um, Top versus bottom, 40 down, 10 up. So who's going to win? The downward force. So we're actually going to move to the left and down. Let's see which one of the answers agrees with our statement. Downward and to the left. Well, look at that. Choice A. All the rest don't make sense at this point because I've already decided what the correct answer will be.